What up, my ninjas? Appreciate y'all for sliding through for yet another video and checking me out. Your boy, the Network Ninja. Today's topic, I'm going to be doing a lab, and it's going to be going over configuring and verifying single area OSPF version 2. This is a ccna exam topic. It's under section 3, which is IP connectivity on them exam topics on that blueprint. If you're following along through that, I'm just going to be hitting those little bullet points and going through that. Just want to shout out to one of my day one ninjas, Anders Tech. He's the one who recommended doing this video. Appreciate that, because it's really hard coming up with this content for y'all, because I don't know what y'all ninjas trying to see unless y'all communicate with me. So appreciate you leaving that comment. So that's why I wanted to go ahead and create this video. So if you're like Anders Tech and you're just looking for just like a simple lab video, and if you don't know, you better ask somebody. Network Ninja, I'm going to break it down for you. I'm going to do the best that I can. PF is kind of a complex topic, even for me. Even doing this lab, I found it is pretty complex topic. So my goal is to just try to break it down to small, manageable, sections for y'all. So if that's what you're looking for, well, you made it to the right place. Because my goal by the end of this video is to provide a resource out there for y'all to share and for you to use and practice with. You should be able to run through this lab. I try to keep it basic as possible. Again, my goal is to get you to really pass the ccna. You can look at all the technical details. You can go through, all the little things that you need to know about OSPF later. My main goal, and like the goal of this video, just try to give you that sauce just to pass the exam, just so you can get that monkey off your back. So if you've been following along with the videos I've been dropping, a couple videos back, I'll put it right there, whatever. It was about configuring IPv4 static routes. Now that lab that I did there was just really basic, where we had just a few routers set up and we had some networks, I think like 3 different networks, and we configure the routes for these routers to say, hey, if you want to get to this network, and you pointed it to interface, or you pointed it to that specific network. So this is kind of like the evolution of that, right? Because yeah, that's simple if you did that, if you had 3 routers and like 3 basic networks. But now, you know what I'm saying, you're starting to evolve, because what if you had 100 networks and 100 routers? You could see after going through that video, or if you've been practicing this, that it's going to take you forever to just sit there and configure a static route to point for this network, network 1, point to this network, network 2, point to this network, network 3. It's going to take you all day. So that's where learning about this kind of dynamic routing, or another way of saying dynamic routing, is just ever changing, kind of constantly changing routing and everything. Learning about these dynamic routing protocols, OSPF being pretty much the big one, for reasons that will take a whole nother video to explain. But that's why learning about it is key, so that if you are faced with a large enterprise network, you know what's going on if they're running OSPF, why they're doing that, because it's not some for the little baby static routes where you could just point to everything. It's a pretty huge network. You got a lot of different networks that you're trying to connect to, and you got a lot of different routers as well within that same network. So that's why learning about this dynamic routing protocol is really, really key to your growth and your evolution. OSPF is a dynamic routing protocol because all the routers it allows them to communicate without any manual intervention by you, other than setting it up and getting the process going. And then it lets the routers exchange that routing traffic and all of that kind of information dynamically without just a human intervention. It's kind of doing it on its own. All right, finna soup up with this energy drink now. What y'all know about that good Celsius? You're gonna need that Celsius, or whatever, coffee, whatever you need. So you know what I'm saying? So you can wake up and lock into this information. Also, really quick, let me do some quick housekeeping right now. If my audio is trash, or y'all want the little matrix background that I put back there, or if y'all really don't care about looking at this background, out of the bedroom, out of my bedroom that I'm recording in. Just let me know in the comments, because I'm really trying to create this content for y'all, trying to keep y'all engaged, you know what I'm saying? So whatever is going to help to keep y'all engaged, because let's face it, this stuff is boring. I don't know about y'all, but for me, this stuff is boring. That's why your boy need that energy drink. That's why, you know what I'm saying, I'm trying to create this content to keep y'all hyped, so y'all can keep going through, learning about this stuff, because it's just going to make you that much more valuable to the marketplace. And once you increase your value, it's game over. It's over with. You're going to get locked in. You're going to get the big salary and all of that stuff. But yeah, if the audio's trash, I got like a little basic Amazon mic. I don't know. It's like the basic one. So if I need to step my game up, y'all just let me know in the comments. Appreciate everybody for commenting and everything. All the love y'all been showing me. But with that being said, let's get to it. Let's get to this lab. I ain't trying to keep y'all for long. All right, yeah, this is just packet tracer right here. Again, y'all, if it's too small, you can't see or something. But yeah, if it's too small or something, I could try to make it bigger. But this is what we working with. Just basic packet tracer or whatever. So we got router 1, router 2, router 3, router 4, and we got a little PC. We got 3 different networks again. Network 00000, 010, 020. Now I done did this lab before, and then I erased all the configs. So we're just gonna start from scratch with y'all. But I did all the IP addressing and everything. I did all the IP and connected all the cables and everything in the switch, and and I configured a little IP address on the computer. It's pretty simple, but I did see somebody in the comments, y'all are wanting the packet tracer lab. I'll try to put it together to where I could share the file. I haven't got to that yet. I'm trying to figure out how to do that like on a Google Drive or something for y'all. But I really encourage y'all, throw up 4 routers. I mean, to just do the IP addressing and stuff, you're going to have to do this in real life anyways. You're going to have to be labbing all the time anyway. So you might as well get used to it and just lab it up on your own time. Like, do one router, like spend an hour and just configure that router, you know what I'm saying? And then spend another hour, do that. You don't got to do it all at one time. Break this stuff down. Just use the same networks as I used and everything like that. So you don't have to like design your own network and think about all of that kind of stuff. But again, I just encourage y'all to do it. It's just going to make it that much quicker the next time you set up another lab. And that's basically how I'm doing it. I'm doing all this, just off the top of the head. You feel me? So suggest y'all do the same thing. But it is time consuming. So you're going to have to set aside some time. But that's all about being more productive and increasing your productivity. So I'm going to be dropping some videos on productivity, how I'm able to, hold down the job and then do these YouTube videos. So to show y'all that y'all can do this stuff too, just as easy. But first things first, to learn about OSPF, we're going to talk about the first exam topic in OSPF, which is topic A or whatever, and it's neighbor adjacency. Basically, just like how the static routes, like this network don't know about this network don't know about this network, so on and so forth, right? With static routes, we would just go in there and put a static route and say, if you need to get to this network, or if you needed to get to like this network or whatever, you would point them to this interface or whatever it was, right? The same thing has to happen with OSPF. They got to be able to communicate with each other and know about each other's networks. But that's the difference with OSPF. It's gonna have a database of all the networks that it knows about for every router. So all the routers need to communicate. So they all need to form this, what they call a neighbor adjacency. And all that means is that they're gonna have to all be on the same page for them to be able to communicate, meaning they're gonna all be sharing the same information. Like this router down here, he's going to know about this network. This router up here is going to know about this network. And how they're going to do that is they're all going to become neighbors. So to begin with, how are you going to form a neighborship, what they call a neighborship, or a relationship between these routers, even though you see we got directly connected links right here. And I got that set up for whatever reason. I did it like that. You could set up yours. It doesn't even need this much, but You can set up yours. And then you got these directly connected neighbors, and then you got neighbors that he needs to be able to know about this guy, and they need to be neighbors as well. So how are you going to form a neighborship? That's where OSPF is going to come in. So to form a neighborship, you have to configure OSPF. And then once you configure OSPF, that's just the routing protocol, then you're going to configure the networks that you want to advertise, basically the information that you want to share. But it definitely, like I said, it goes more in detail with that about the different neighbor states that it goes through, because the information that you share, it's a lot of information that you share. You got to know, let them know what subnet you're on. So you, first of all, to be a neighbor, you got to be on the same subnet. So these two are on subnet 10.0.0.0/30. So they can become neighbors, right? But that's what you're going to be advertising. You're going to have to advertise what subnet you're on. You're also going to have to advertise what they call a router ID. Same thing, just like a regular, like a ID, like your driver license or whatever. That's what a router ID is. It's a way to identify your uniqueness throughout the network, so people don't get confused with who's who, because no two router IDs are allowed to be the same, right? And again, there's more details on that. By default, for a router ID, it's going to be the highest loopback IP address configured, right? And if there's not a loopback, it's going to be the highest IP address configured period on that router. So again, you could fact check me on that, but it's basically, there's rules to even just establishing a router ID. When we want to form a neighbor, the very first thing you do is we're going to go in there and we're going to configure a router with the OSPF router protocol, and then we're going to start advertising our network. Once you start doing that, it starts sending out these OSPF hello packets. And inside those hello packets is going to be like, hey, I know about network 10.0.0.0, or I know about network 10.0.2.0, or whatever other networks that you know about. It's going to start, if you got more networks configured on you, it's going to start advertising that. So when it's sending out these hello packets, it's just looking for any neighbor. So once we configure a router and then we start advertising the network, it's going to start sending out hello packets saying, hey, is anybody out there that can speak OSPF? And then this guy, once we configure and start advertising the networks he knows about, he's going to be like, yep, I speak OSPF. And then he's going to start saying, these are the networks that I know about. And it's a whole process. Then they're going to start exchanging that kind of information. And then he's going to be like, this is my router ID. These are the networks I know about, and everything else that they need to know about. Type of networks he knows about, because there's different types of networks that we're going to talk about here in a second. They need to know the most recent link states about each of the links that they know about, or the networks that they know about. So they're going to go through this whole process of forming that neighborship and going through all these different states. And once they do, that's when they become fully adjacent. Once they exchange all of that information, he's like, you got it? And then he's going to be like, yeah, I got everything. He said, you got everything? You got all my networks, everything? After we go through all of our stuff, now they're going to come up and they're going to be fully adjacent neighbors. Let's go ahead and start to configure OSPF. We'll start up here. I'm going to call this one router 1. As you see, host name right here is router 1. Then we got router 2, router 3 here, and router 4 right here. So we'll start here with router 1. All right, let me just make sure there ain't no OSPF config on here. Okay, there's not. And then just to show y'all, we got a loopback IP address right here. And we got the IP address 10.0.2.1, which is the serial interface right here of this guy, just to show y'all. This is 10.0.2.1, and if it's a /30, this got to be the .2, right? 10.0.2.2. So what you want to do, it's very simple to configure it. Go into config mode, then you're going to go router, OSPF, and then it's going to ask you for a process ID. This is locally significant. When I say that, it means that it doesn't matter. Only the router that you're configuring cares about is process ID. So that means it could be 1 on this router, 2 on the next one, 3 on the next one, 4 on the next one. But this is a lab and we're learning, so just keep it simple and just leave the process ID all the same as 1. Then you're going to put the networks that you want to advertise. You want to advertise this network because that's a network that you're directly connected to on your router, and you want other routers that are running OSPF to know about it. So to advertise that, you're going to go network, and then it's asking you what network, 10.0.2.0. And then this uses a wildcard mask instead of a subnet mask. So again, wildcard mask, that's just another story for another video. I could show y'all how to easily convert a subnet mask into a wildcard mask. It's just taking 255 minus in the subnet mask, and that's how you get the wildcard mask. But this is going to be .3. That's how I got the wildcard mask right there. And then the next thing you got to put is this area command, and you need to set it to area 0. Now the areas, let's talk about that real quick. All these routers are going to be in the same area. That means that any OSPF router, whatever area it's in, it has to, and it wants to be neighbors, it has to be in the same area, because you could have 4 routers like this all in the area. But again, this is a lab. What if you're in an enterprise business and you got 100 routers, right? It's starting to get a lot, and that database and networks and everything will start causing your CPU, the processors, to process all of the information that they're sharing, all of the networks and everything. That's why you're going to have to start getting into multiple areas. But again, that's out of scope for the ccna, but that's what the area does, because if you had those 100, you could split like 50 routers into area 0, and then you can create like an area 51, which is another area with 50 more routers that have their own set of database of networks, which they call the link state database. So you could have 2 different databases and networks, and then they would be able to share that in different areas and still be able to communicate between an area border router. But again, another time for another video. So this one, we're just going to do, all of these are going to be sharing all the same information, so they're all going to be in area 0. So boom, like I said, right now he's on this interface. Who's ever on this subnet, he's sending out packets saying, hey, who's speaking OSPF? Is there anybody out there speaking OSPF? I want to become a neighbor with you. But since we don't got nothing configured, ain't nobody talking back to him. So what I'm going to do here is put this. That command is going to just display the logs onto the console. That command's logging console. So that's just a little gem from the Network Ninja for you. So you could do that too. That way we can see the logs once they start becoming fully adjacent and they start exchanging all of their information and everything. So we'll just go in, and we'll just move on to the next router 2. So again, we're going to pull this guy up, get in privilege mode, and then let's look at what he got. And then we want to do a show run, make sure I don't got no OSPF configured. So no OSPF configured, but look at here, I got gig 00 has a network, and serial 030 also has a network. So for that, I'm going to go into config mode, then do router OSPF, that same process, which it doesn't matter. I could have made it a different process. We're just doing that for the lab. But this matters. If I want to become a neighbor with this router who is on this network, I need to advertise that I'm on that same network. So we're going to go over there to do that. So again, the command network 10.0.2.0.000 wildcard mask .3, and then almost forgot, you got to put area 0 again, because that all's got to match, because that's the information that they're going to be sharing. So let's see if we could catch it over here once they become fully adjacent. Boom. You see, it went, we caught it. It went from loading to full. Loading is done. That means that they were asking each other, as soon as this starts the process. Actually, it starts saying, hey, is anybody speaking OSPF? But then this is what says, hey, I'm on this network, or this is the network I know about. But we still need to advertise this guy, this network that's running on gig 00. So let's take a little closer look at that. So if I do a show run section or begin gig, right? Look at gig 00. You see that 255, 255, 248. That's the subnet mask, which is /29, right? That's a different network than that 10.02. You see, this subnet mask is on a /2 or /30 or 255, 255.252. So I want to advertise this, but for this one, I'm going to show y'all a different way, because the test is going to test y'all on, that's not the only way to do it with that network command. You can also do it on a per interface basis. So let's go ahead and go interface gig 0/0. And then the command for that, if you want to start advertising GF on this specific interface for this specific network, you're going to do IP OSPF. You got to put that process ID, which was 1, and then what area you're in, area 0, and then that should do it. So now what's happening is, so now after doing that, this router is saying, hey, I know about 10.02 and I know about 10.010, and I'm in area 0, and I'm on, and the process ID is locally significant, so that doesn't matter. All right, so these two are OSPF neighbors. We got that configured because we seen that they're OSPF neighbors because the log came up and showed that they were OSPF neighbors. But we're gonna have to do the same down here with these two and make them become OSPF neighbors as well. But before we do this, I'm gonna jump into this computer and we're just gonna do some ping tests, which I should have did before we even made them neighbors and they started sharing information, just to see what he would be able to reach. Because he's on this 10.01 network. Let's see if he can reach the 10.02 network right now. So if we go here, all right, so now we're logged into that PC. This PC, we're logged into it and we just went to command prompt for it, right? Let's blow it up. And let's just see 10.0.2.2. Let's see if he can make it over to that other network. And as you can see, he getting destination host unreachable. Basically, he can't make it to that network over here, even though these guys are OSPF neighbors. And that's because the 10.0.11, his gateway, which is this guy, doesn't know how to get over there. So let's see if he can make it to 10.0.12. Yes, as you can see, he can make it to 10.0.12, which is this guy right here, because that's on that same subnet, but he can't make it over to this guy. So yeah, guys. So if we want this PC to be able to reach that network 10.0.22, the default gateway 10.0.11, which is this router right here, he also needs to know about this 10.0.2 network. This guy, since he's not connected, he doesn't know about it because he's not running OSPF. But if we put him in OSPF in the same area, then he's going to know about this. That way, when he sends the ping out to get to this network, it's going to flow through here, hit this switch, go to the default gateway, and the default gateway is going to send it over to this guy because he's going to know that 10.0.2.2 is hanging off of him, because he's going to be advertising that network because he's advertising it to this guy that he knows about it. So that's the whole point of OSPF, as you can see, is because you want somebody that's on this network, that's somewhere at a different address, you want them to know about this address and you want them to know about this address. He can't even get to the 10.0.0.0 network. This PC can only get here. His default gateway's here. He can get over here and ping over to this guy because he's directly connected. But without OSPF running or any routing protocol or static routes or what have you, he's going to be locked in to only knowing about this network. And that's the whole point of what we're doing with OSPF. Hopefully all of this is making sense. All right, so now let's move on. We're going to go into this router. We're going to drop that same config and this router that we dropped in, that same OSPF config. And basically, we're just getting them all on the same page to where they're all speaking OSPF and they're all going to be sharing their network information and everything. So let's log into this guy. We're going to do enable, show run section OSPF again, right? So check me out, right? Still no OSPF. And then if we do show IP int brief, look again, we got this network on the gig 00, which is the same network right here. that 10.0.1 off his gig 00. This is the one that he's already advertising for OSPF, right? And we got this 0.30. So that's what we want to do. We want to go into config mode, go router OSPF1. Again, that process ID could be locally significant. It doesn't have to be one, but for the lab, we're trying to keep all of this on the same page. Keep it very simple. So now we're going to use the network command to advertise our serial link network, which is 10.0.0.2, 10.0.0. That's our IP address, 10.0.0.2, but the network we're on is 10.0.0. It's a /30. So again, that translates to a wildcard mask of 0.0.0.3, because all you have to do is take 255 minus the mask, which is 252. So 255 minus 252 is 3. That's how I got that number. Again, if you want me to give you that simple little hack, let me know in the comments. I'll do a video on just converting subnet masks. It'll take you like 2 seconds to learn that. And then we got to put them in area 0. So now he's saying, hey, is anybody on this network? Is anybody out there? Since we don't got anybody else configured for this network, nobody's responding to him. So let's exit out of here. Then we're going to do IP OSPF. Oh, I'm sorry. We're going to do interface gig 00, right? And then we're going to do IPPF. What's the process ID? And then what area you're a part of. Once we do this, he should become a neighbor with that router that's also saying, hey, I'm on this gig 00 network as well. So hopefully this don't make a liar out of me. Let's see what happens. Let's exit out of here. Do that command. Let's see if it comes up. Boom. Router 2, just like I said, it took a few seconds, had me a little shook, you know what I'm saying? But in Network Ninja, we hang in there, and then we went from loading to full. So now we did it 2 ways. He's saying, hey, is anybody on this network? Nobody responded. Nothing happened. But as soon as we configure OSPF to be on this interface, which is on that same network as this router, he went from loading to full. All right. So now let's jump over. He's done, right? So now if we do that ping over to the 10.0.2.2 right here, again, my theory, it should prove it. He should be able to ping over here and say, where's that 10.0.2.2? And since this cat's sharing information, he's an OSPF neighbor, he's going to be like, oh, my boy up here, he know about 10.0.2.2. And then he going to shoot it over there to him, and then he going to get it, and then it's going to reply back to him. So boom, let's go in here. All right, so boom, we back in there. So 10.0.2.2. Let's see if it responds. Boom. I hope this is making sense, y'all. I hope this is making sense. If it is, definitely give your boy a subscribe if you're learning something, right? Or if you just want to keep following, or you got to rewind this video and watch it over again, because hopefully it's making sense right now. Hopefully it's clicking, but now he can reach it. Before, he couldn't reach it because the default gateway, this guy didn't know how to get there. But once he became neighbors, now he can get over there to that 10.0.2.2. So the next part, we got to make him become neighbors with him because they're not neighbors yet. So let's jump over here to him. Do the same thing. I'm going to get in privileged exec mode. Then I'm going to do show run OSPF just to make sure ain't got no OSPF. Now we do show IP in brief. Look, the only network here that we need to configure is this network. So we're going to go config mode, router OSPF1. He's going to be like, hey, I'm speaking OSPF. But for what network do you know about? I know you speaking OSPF. But what network? Oh, I'm on the 10.0 network, and my wildcard mask is, and then the .3, and I'm on that network, and I'm part of area 0. Again, it's going to take a few seconds, but we should be able to catch it. So boom, you hit enter, exit out of there. Boom, took only a few seconds, and it came right up. So now, these neighbors with him, or this router is neighbor with this router is a neighbor with this router, and this. So now we know that they're all neighbors. But what we want to look at, so that's just neighbor adjacencies, right? So now we're going to go into, since we configured OSPF and we know that we got OSPF configured because we seen that it went from loading to full, and all of them are neighbors and they're sharing information. And we even did like a little ping connectivity test, and we seen that they're getting around. But we just want to learn how to verify this kind of information, because that's what the exam's going to want to test you on. Can you verify what network type they might be on? Because there's different network types. With these serial connections, by default, these network types are point-to-point network types. When I say point-to-point network, that means that there's no other router but you on this network. It's just a one-on-one. There's no other routers. Now, this network type here is on a gig 00. By default, gig 00 is what they call an Ethernet interface or a LAN interface, right? And serial is a different type of interface than a gigabit interface. So by default, on an Ethernet interface like gig 00 or fast Ethernet 0, that's another Ethernet interface. By default, you're going to have a different type of network. But first, let's look at the serial point-to-point network type for this. Now, this can be a different type of network. You can configure it to be a different type of network. But again, we're keeping this simple. We're just trying to learn OSPF. So let's log into right here, this router. If we do a show IP OSPF neighbor, this is going to show us some information right here. This is key information for when you're trying to verify your OSPF neighbor adjacencies. What do you have here? You're going to have a router ID. So that's your neighbor's router ID. That's not your router ID, just like it says. That's your neighbor's router ID, what state it's in. Because remember, I said there's different states that it goes through, and those are the states that you're going to have to study. I'm pretty sure that they're going to make you learn those states. And full means that we're fully adjacent neighbors, meaning we've exchanged information. We told each other about the network types. We've told each other about everything that we need to know. Then right here, this is the address of your neighbor, the IP address of the neighbor, and the interface that neighbor has that IP address configured on. Again, this is all the neighbor's information. The neighbor's interface, which is 0030, and his IP address, which is 10002. And this is his router ID. So you know it's because you can have more than one neighbor, right? But not on a point-to-point connection. But you know that this is the neighbor's router ID. So how do we know that? Now the question is, we know that this neighbor, but how can we look at the network types? That's the next question. What type of network is he on? Is he on a point-to-point network, or is he on a broadcast network type? We don't know that. So the command to figure that out is you can use two commands. I'm going to show you two. You can do show IP OSPF interface, and that's going to show you any OSPF interface you have configured, which is 0030. This is a lot of information with show IP OSPF interface, right? It's going to say this is local for you now. This is your 0030. This is your IP address you have configured for it. This is your router ID, meaning router 4 is router ID. And here we go, network type, point-to-point, and you're on a point-to-point network. Then we have some other information here that's good, right? The hello interval and the dead interval. These are timers for those hello packets that are going out to form that neighbor adjacency. So this is part of that. When they send out them hello packets, it's also saying not only what network I'm on, what network type I have, it's also saying, hey, these are my hello and dead timers. These timers need to match. If I change that, this neighborship will fail because everything needs to match for them to become full neighbors. It even tells you what neighbor you're adjacent with, as we've seen up here in show IP OSPF neighbor. That's what neighbor this interface is adjacent with, which is neighbor 3 right there. But this is a lot, so what I like to use instead of that one is show IP OSPF interface brief. Boom, you get the same kind of information. This is all my OSPF speaking interfaces. This is mine. This is the IP address I have configured, the subnet mask I have configured for it. And again, here's the state, point meaning point to point. That's what kind of network type I have. Now let's hop over here to router 3. We're going to look at that show IP OSPF neighbor command again. Now we got some different stuff going on here. We got two neighbors here. Remember, this cat right here, he's neighbors with him, but he's also neighbors with him on another interface. He's got two OSPF neighbors. So let's take a little closer look at that with the two OSPF neighbors. So first we'll look at this one. That's our neighbor ID, router 4. The state is full. That's the IP address of my neighbor, not mine, my neighbor's IP address. And this is the IP address, the interface that my neighbor is using for OSPF, and that he has this IP address configured on, which is serial 030. Now let's look at the other neighbor 2. Our state is full, but then we see this BDR. I'm going to talk about that in a second, but let's just keep on pressing through. Then we got that neighbor's IP address 10012. Then we got the interface that he's configured on, right? That 10012 is configured on my neighbor's gig 00 interface. So let's talk about this BDR right here. When you're on this broadcast network type, there's certain OSPF rules that have to take place for you to become neighbors. When they're forming their neighborship, before they became neighbors, they say, hey, they sent out that network type, said we're on a broadcast network, meaning there has to be a BDR election. So DR stands for designated router and BDR stands for backup designated router. And the reason why this has to take place is because right now it's a simple network. We just have two routers, but what if I had another router connected to this switch and another router connected to this switch? This router knows about this network and this router knows about this network. But what if I added like two more routers that knew about 5 networks and then another router over here that knew about X amount of networks? That's a lot of OSPF routers sharing information about a lot of networks. So that means that if this network went down, he would have to update this guy would have to update this guy, he would have to update this router over here and another router over here. This can become problematic, and this is why they call OSPF, you might hear referred to as a chatty protocol, meaning it consumes a lot of your CPU resources because it's a link state routing protocol, and it has to tell everybody about everything that's going on with its link states and everything like that. This link is up, this link is down, or whatever. And that's going to bog down the network if your CPU, instead of routing traffic, what you wanted to do, if you wanted to route a ping, that ping is going to go so slow because if a network goes down, he's got to wait till he updates all of his information with this neighbor and this neighbor. Let me throw some routers. So he would have to wait till, like, let's say this link down, this router would have to wait till he gets a full update. He would have to wait till he gets a full update, and he would have to wait till he gets a full update before they can process all of the information because this network had went down. So that's why that can become super problematic. That's where this concept of DR, BDR comes into play, because what happens is instead of everybody telling everybody else about all the networks he knows about all the networks he knows about, all the networks he knows about, all the networks he knows about, they all say, hey, we're on this broadcast network type. Since we're all going to be sharing information, what we're going to do, because remember, this is point to point. It's only one-on-one. There's nobody else here. It's just me and you talking. So I'm going to share whatever information, you're going to share whatever information. But when you get on this Ethernet interface, the network type changes to broadcast because there can be more than one router speaking OSPF. And instead of everybody sharing information about all these other networks, what they do is go through an election process, which you're going to have to learn about the whole election process, how they elect the router. It's similar to your STP study, just like how they have to elect a root bridge. And there's a protocol for that. There's a protocol for how they're going to elect this DR router and the BDR router. So they're going to say out of these two routers, they're going to be like, all right, we will elect you as the router. And instead of sharing all the information with guy and this guy, everybody's just going to say, hey, one dude, we're going to share it just with this one cat right here. He knows about all of that. And then this cat in turn, he shares out information updates about everybody's business pretty much. He shares about all of that stuff. So if something goes down with him, he's going to be like, hey, router X had something go down. Router X had something go down. Router X had something go down. And then the BDR, which we seen this one is just in case if this DR fails, your BDR is going to know about all that other. He's going to take over. And then he's going to become the DR until another BDR can get elected. And then if you're not a DR or a BDR, you're going to show up. That's when you'll see right here. Instead of BDR, you're going to see full and druther, meaning druther is just you're neither a DR router and you're neither a BDR router. You're just one of the routers that is just sending information to a DR router or a BDR router. Hopefully all of that made sense right there. So that's where that BDR comes into play. All right. So again, we could do show IP OSPF interface to see all the OSPF speaking interfaces. You see the difference here. We have two OSPF speaking interfaces, serial 030 and the gig 00. Again, the same information is being shared here. This is my IP address. This is my router ID. But here, my network type is broadcast, where here my network type is point to point. And again, you got your hello and dead intervals and all of that good stuff. But again, if you don't want to look at all of that, you can do show IP PF interface brief. And boom, look, you got the state here is point to point. And then the state here is going to be DR. That's showing you that this is on a broadcast network type because there's a DR. And this is your state, DR, right? You're the designated router because if we do show IP OSPF neighbor, this is your neighbor's information. That's a BDR. But this is all your information right here. I'm the DR on this network segment of this 10011 network with this /29 or 255 subnet mask 248. I'm the DR on there, and you can see that quickly by doing show IP OSPF interface brief, and then you got the point-to-point network right there for that. So that's two ways where you're verifying that information there. So finally, now that we see and we verified that everybody is an OSPF neighbor, we looked at the different network types that they're on, both the point-to-point and the broadcast. And I mentioned about these router IDs, but again, these router IDs, if we do a show IP interface brief, the router ID is being selected because it's the highest loopback IP address. Another way that you can manually configure it, by default, OSPF says, hey, do you have a loopback interface? And this router does. And then it's going to say, hey, what's the IP address on that loopback interface? If there's more than one loopback interface, it's going to pick the loopback interface, meaning with the highest IP address, meaning like if it was 10, it would pick that because 10 is bigger than 3. Or you can go into config mode, router OSPF 1, and then you can just use the command router. This is to do it manually. And it's just going to say, hey, what do you want the router? This will override that default. I can change it to 5.5, right? If I wanted to. So let's clear. It's saying to clear the process for it to take place. So if we do clear IP OSPF process, we only have one process running. So reset all OSPF process, yes. So it just did that. Let's swing over to this neighbor right here. And let's look at his OSPF neighbor now. Now let's go into privileges and let's look at what this OSPF neighbor is looking like now. Notice before when we did OSPF neighbor, it was router 3. It was a loopback IP address of our router 3 right here. It was that loopback IP address 3.3.3. But right here we manually configured it to 5.5.5 with the router ID command, and now it's 5.5. That's the ID of it. So it's not an IP address. It can be an IP address by default, but it also can be manually configured. Again, hopefully all of this is making sense. So finally, let's see, now that we know that everybody's neighbors, let's see if this PC can make it over here to 10.0.0.0.1 IP address. So if we go in here, we should be able to ping it, right? So here we go. And we can. And the reason why, that's on a totally different network, because if we go here, IP config, right? Space / all. I'm on 10.0, my IP address is 10.0.1.3, but I can ping 10.0.0.1, which is a completely different network. And the only reason why we're able to do that is because OSPF is running and they're sharing that information. All right, my ninjas, I know that was long and drawn out, but let me know how I did in the comments. If everything kind of made sense, if you need me to redo this video, I'm gonna redo it. I just wanted to get it out there. I'm gonna use the same lab, but I'm gonna try to break it down a little bit better. Hopefully it did make sense. If it did, definitely hit me with that subscribe. I appreciate the support as always. Again, for everybody sliding through, tapping in with me. Also, let me know in the comments what you want to see. If you want to see more about the wildcard mask, or there's more stuff I could show you about the link state database. That's the whole database of all the links that it's sharing and a breakdown of that, because there's different kind of link state advertisements. You got type 3, type 4, type 5. We could go over all of that kind of information. And again, this is single area OSPF, but when you start looking at all of that other stuff, that's for multiple area OSPF, which is really not needed for the ccna exam. I'm really just trying to get y'all to pass that ccna exam, and then you could start progressing forward with that. Again, like this video, comment, please comment, let me know what's going on, if the audio is trash, whatever, and subscribe. And you already know, because I'm coming with another video every Sunday at 9 p.m. every week. Expect a video from your boy, the Network Ninja. I'm gonna holla at y'all on that next video. Peace.